Hi, yeah, I have a question about the titration, I clicker question on the class. This question.
Uh-huh. So this is a titration question.
Yeah.
So what do you know so far about titration?
I know so far we learned three type of titration.
Do you know what are they?
Yeah, the strong acid and strong base, the strong acid and weak base, the strong base and weak acid.
Okay, that's great. So we have this question, and what kind of things like matters you can see in this question?
HNO3 and KOH.
Okay, that's great. So what is HNO3?
It's kind of acid.
Is it strong or weak?
Strong?
Yeah, that's right.
Okay.
So for KOH, is it a strong base or strong acid? I mean, strong base or weak base?
Weak?
No, KOH actually is a strong base.
Okay.
Do you know why?
Why?
Because in the period table, on the first two group, the first group except the hydrogen, they are all strong base, and for the second group, calcium and magnesium, those are like heavy metal. Those
Okay.
are strong base. Just remember them, okay?
Okay.
So since it's a strong base and strong acid, so what kind of equation are you gonna use? I mean, what kind of table are you gonna use? We have learned two kinds of table so far. One is IC,
ICE table?
and another one is ICF, forward.
Okay.
ICE table is like and it's strong base and strong acid, and you have to put the number in the unit of mole, MOL,
Yeah.
to calculate in this kind of question.
Yes.
So since we have a strong acid and strong base, are strong acids and base gonna completely dissolve in the water?
I think so.
So what kind of ion do you have in this kind of in this solution?
I think we have H plus,
Yep.
NO3 minus,
What else?
K plus, OH minus in the final solution.
Okay. So H plus is a strong acid. NO3 minus is a
Strong is, I
no
don't know.
is a conjugate base.
Okay.
It's conjugate base and it's a spectator. It doesn't react in the solution because it's from a strong base. It's from a strong acid. Strong acid, then it's a conjugate base. For strong acid, the conjugate base is always spectator.
Okay.
So same for K plus. K plus is also a spectator, right?
Yeah.
So OH minus is strong base.
Strong base. Yeah.
So what kind of reaction gonna happen in this solution?
H plus react with OH minus to form water.
Yeah, I can write down the equation, the reaction. Okay, so read the question again. Can you see how many moles of hydrogen and how many moles of OH you have?
We have 0.1 mole of hydrogen and 0.2 mole of OH minus.
No, that's not mole, that's mole liter.
Okay.
That's concentration. So for mole, you have to use the volume times mole liter to get the moles.
All right.
Okay.
So it's 0.1 times 20, 0.02 liter. We get 2 times 10 to the negative 3 mole of H plus.
Yes. And how about OH minus?
It just says 0.2.
And read the question.
What's this?
After the addition.
Oh yeah, so 5 milliliter 0.005 times 0.2. 1 times 10 to the negative 3 mole of OH minus.
Yes. So this is SAE table.
Yeah.
Those numbers should be at the initial, right?
Initial?
Yeah.
Oh,
so
right.
I stands for initial, C stands for change, and E is end.
Okay. Okay.
In this case, we don't really need to care about the water because it's always in the solution. So just kind of,
Okay.
you don't need to care about that. So, things you have, what kind of things you have like more? You have more,
Hydrogen.
yeah. So you have
Yeah.
more hydrogen. So which one is gonna be used up?
This one.
Yeah.
OH minus, yeah.
So what's the change gonna be?
It will be minus
One,
1, and this
one.
minus 1, and this become 1 times 10 to the negative 3. This become 0.
Okay. So far so good. So after the whole reaction, what can you find? What things gone left in the solution?
The hydrogen ion.
And what else?
Water.
Remember, you have two spectators.
Oh yeah, we have 2 spectators.
So what are those?
H plus, O3 minus, and K plus.
Can I see the answer?
Yeah, so the answer would be 3, 5, and yeah, the answer should be B, right?
B.
No.
Yeah, that's
Okay.
right.
Okay.
So you already know how to solve kind of this question, right?
Yeah.
Good, great. Do you want to see another similar problem? Maybe like weak acid and strong base, or weak acid?
Sure.
Okay, let's find another question. Where is it? Come on. Okay, let's see this question.
Okay. This asks for pH, right? I don't know how to do this kind of question.
This is not titration, but you can use the titration. Same thing to this kind of question because it's called buffer solution. You just have a new equation to solve this kind of question. It's called HH equation. So once you see a buffer solution formed by weak acid and weak base. So once you see kind of those stuff, you just use HH formula, which is pH equals pKa plus log x over hx. X means conjugate base, and hx means conjugate acid.
Okay.
You just need to find the concentration of the conjugate base and conjugate acid, and you need to know the You need to know the Ka for this kind of question.
Okay.
So just follow this just follow this step and to solve this question.
So we can use Ka equal Kw water divided by Kb, right? Because
Yeah.
it's only given the Kb value. And we got 5.5 times 10 to the negative 10.
Yeah, they already give you the concentration of the conjugate base, which is
0.1 mole.
and the conjugate acid is
0.2.
So you already know the Ka, then you calculate for pKa. You know what's pKa, right?
Yeah.
pKa equals negative log Ka.
Right.
Okay, you got Ka.
It's gonna be
Okay,
9.25.
yeah, that's right. So what's the final answer?
And it's need to plus log 0.1 divided by 0.2,
Mm-hmm.
it will be 8.95.
Yeah, great. That's right. So you know how to do those kind of questions, right, in the exam.
Yeah.
Okay.
Thank you.
I think that's all.